Okay, picking up with where we left off, I've actually shifted to a different specific file we're going to be working with because the one I started demoing on had a worthless DZDT signal. So we'll pick up here. We've just created the DZDT channel. What we want to do is a tiny bit of homework, so-called, before we take our next step within the file. We want to look at a prototypical DZDT signal up close. So I'm just going to show this from within the video so you can see it and not have to tab off of anything. This pink signal here is a prototypical DZDT signal. So it has the same rhythmicity, a similar rhythmicity to the ECG signal. We can see from this R spike to R spike is one heartbeat. This is a similar cardiac cycle. It's just on an off phase part, kind of in the middle of one heartbeat to the middle of the other. So this is still the same cardiac cycle, just different relevant points in it. So our DZDT signal has a B point, which is kind of this notch that we talked about typically right before the slope gets really steep and it heads up to the C point, which is the peak. And then it comes back down into a valley. The next low valley after the C point is your X. And then the next peak after that X point is your O. Sometimes you'll see a Y in there. Here's a perfect example. Here's Y is the next peak after the X. And then if there's room for another peak, that'll be your O. So sometimes you have B, C, X, O, and then sometimes you have B, C, X, Y, O. But less relevant to, that may be less relevant. What you really need to do is make sure you see some cycles that look something like this. A little blip before, a tall peak, and then kind of a small hill afterwards, and then a new peak. So that's what we're looking for. Now we're going to go back into our DZDT signal. And what we want to do is zoom out to see the whole file as it came in. And that's this button right here. It auto scales a waveform horizontally, which means basically it puts the whole experiment for this day, for this subject, in one view. So it's like a way zoomed out thing on the time scale. We see a whole lot of terrible noise right here, which is going to be a pain to data clean. But before that, we have some nice clean stuff. So we're going to go ahead and zoom in to the least noisy place we can find. I'm thinking it's this. The less fuzz, the better. So this is nice and smooth looking. So we grab our zoom tool. We zoom in here. And that looks pretty good. Now hopefully our scale is going to kick in here. We'd like to zoom in a little more than that. It should be auto scaling at this point. Let's try this right here. This will put it in auto scale mode. That's better. And we can hide this raw signal. So I'm going to hit my Alt key and click on this so we can see a little better what we're doing. Now there's fuzzy over here, but clean over here. So I'm going to zoom in a second time into this little data swatch. Still looking nice and rhythmic, but it's still too glommed together to see anything. So I'm going to just keep going right here. And now we've spread our signal out to where we can see it pretty well. I'm probably not going to be choosing these as my representative cycles just because there's a big change in kind of how it's rolling and moving. But I kind of look for a few of these right next to each other that look pretty representative. These two look quite similar, which is going to make my job easier. So I'm going to zoom in on this. That's going to be what I use to do the next step. Which is to highlight a representative cycle, which we're going to do in the next video.